Okay, how you guys doing? Hopefully you're doing well. Hopefully you guys had a Merry Christmas and having a Happy New Year so far. Just a few things. Make sure that you keep reading your emails, guys. We're starting a new semester here. Most of you do pretty well with it, but make sure you read your emails at least once a day. I don't send you emails every day, but I usually send you emails at least a couple times a week. And again, if I send you something, it's not just to say, hey, how's it going? It's because there's something important I need to tell you. So make sure you check those. Also, we're about ready to start a video on our first math assignment. You actually have an assignment that was given to you over the weekend. This is actually, I'm posting this. I'm going to post this on January 4th. It's actually December 30th right now. I want to get things done a little bit ahead of schedule. But I'm going to send every one of my math students an email over the next day or two. And your first assignment, it's an actual assignment, okay, is you need to respond to it, okay? It basically tells how some of the differences and how the semester is going to be run this semester. But you need to email me and tell me that you received the email and you've read it and you understand it. Or if you have questions, you can ask me questions about it. So, but anyhow, make sure you read your emails. So anyhow, we still have 4 more sections of trig. Then this class is called FST, Functions, Statistics, and Trigonometry. We have 4 more sections of trig. Then we'll get into the functions and statistical part of it in the second semester. So we still have 4 more sections to get through. The first one, section 4-1, we're starting chapter 4 now. There's sections 4.1, 4.2, 4.3, and 4.4. 4.4 is very, 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 very easy. You're going to like that section. We're going to spend like a day or two on it at the most. This one's not too bad. Okay, sections 4.2 and 4.3, that's a little bit tougher, a little more intense. So you're going to need a calculator, okay? It doesn't need to be a graphing calculator, but a scientific calculator. You're definitely going to want a calculator, so you want to grab one of those, okay? And we're going to work through section 4-1. And again, this assignment, this video, I'm going to post it on Monday, January 4th. We're going to have a homework quiz over it this upcoming Thursday. And homework quizzes are going to be done just like usual. Okay, so January 7th at around noon or so probably is when we're going to have our homework quiz over section 4-1. Okay, so anyhow, good news is we're done with the unit circle. We're not going to talk about the unit circle anymore, okay? We're still doing trig, but we're not going to be doing the unit circle. I mean, when you think of trig, I mean, I would hope you thought, well, we're going to deal with triangles. And we haven't been doing a whole lot of triangles. We've been dealing with circles, like unit circles and so forth. But from this point forward, we're just going to be dealing with triangles, okay? We're going to be solving triangles, okay? And when you solve a triangle, what that means is there's 6 parts to a triangle. There's 3 angles and there's 3 sides, okay? They're going to give you some of the information. You need to come up with the rest of the information, okay? They'll always give you 3 things, okay? They'll give you like 2 sides and an angle, 2 angles and a side, 3 sides, look, or whatever, and they ask you to fill in the rest of the information, okay? So we're going to be drawing triangles and we're going to be solving triangles, okay? And we're still going to be using the trig functions, but not the unit circle. That's not really going to work so much, okay? So this section, section 4-1, I don't think it's too bad. It's not as easy as 4.4, but 4.1's not that bad. So just a few things we have to talk about when we're dealing with triangles, okay, is this. When I give you a triangle, in this section, 4-1, we're going to be solving right triangles, okay? Just right triangles. Sections 4.2 and 4.3, we're going to be solving non-right triangles, okay? Triangles that do not have a right angle in them, okay? So if I give you any triangle, be it a right triangle or a non-right triangle, doesn't matter. I'm going to give you one that doesn't look like it's a right triangle. Okay, you need to understand some basic things is this. You denote angles by capital letters, okay? So I'm going to say this is capital A, this is capital B, and this is capital C, okay? You denote sides by lowercase letters, okay? And if we have capital A here, side A is opposite angle A. Here's angle A, here's side A. Here's capital B, here's lowercase b. Here's capital C, there's little c, okay? So capital letters denote angles, lowercase letters denote sides, and they're always opposite from each other, okay? So we're going to dive right in here, and again, you're going to need a calculator, and I got one right here. We're going to start on section 4-1. There's a couple other things we have to talk about. We'll deal with that when we come to it, okay? Let's look at question number 9. Question number 9. They give us a triangle, okay? And they give us theta, 12, and 5. Theta, where's 12 at? 12 and 5. This one's actually going to be a really quick one, okay? So I told you way back when there's a couple of special triangles you wanted to know. A 3, 4, 5 right triangle and a 5, 12, 13. If you know that, you know this is 13 right here. Okay? If you don't, you'd have to use the Pythagorean theorem. 12 squared plus 5 squared is x squared. You do all that, and you'll know it'll come out to be 13. But if you just memorize it, it makes it a whole lot easier. They ask us for all 6 trig functions. So this is a little bit of review from previous stuff. So sine of theta, cosine of theta, and tangent of theta. Cotangent, secant, and cosecant of theta. Okay, so theta is the sine is opposite over hypotenuse, 5/13. So cosecant is 13/5. Cosine, SOHCAHTOA, is adjacent over hypotenuse, 12/13. So secant is 13/12. And tangent is opposite over adjacent, so 5/12. Cotangent is 12/5. That should be a real simple one. Okay, nothing hard there. Okay. We look at question number 11, 2, 3, and then theta. And these are right triangles. Everything you deal with in this section 4.1 will be a right triangle, 4, 3. Well, this is another easy one. Oh, no, it's not 4, 3. Darn it, that's number 10. Darn it, what about a 3, 4, 5? This is a 2, 3. This is not a special triangle. 2, 3 something. So, we use the Pythagorean theorem. 2 squared plus 3 squared equals c squared. 4 plus 9 is c squared. 13 is c squared. We square root it, and c is square root of 13. And we want the exact answer, the square root of 13, okay? And you could say plus or minus. The hypotenuse is always positive. Here's the deal. Everything's positive now. We're not dealing with a unit circle, okay? So everything is positive. This is not positive 12 because it's to the right. It's because it's 12. We're not dealing with a unit circle. Every length is going to be positive now, okay? So we have sine, cosine, and tangent. Sine of theta, and that's what theta is, isn't it? It's on the bottom. No, it isn't. I need to put it in the right spot. We got them all wrong. Okay, theta's up there. Sine of this angle is opposite over hypotenuse, 2 over radical 13. We times the top and bottom by radical 13, you get the radical off the bottom. You're going to have 2 radical 13 over 13. Cosine is adjacent over hypotenuse, 3 over radical 13. Times by radical 13, you're going to have 3 radical 13 over 13. And tangent is opposite over adjacent, 2/3. So cotangent, secant, and cosecant. Flip 2/3 for cotangent, you get 3/2. That's a 3, it's supposed to be. I'm not going to flip this one, I'm going to flip that one. It's going to be radical 13 over 2. And I'm going to flip this one, radical 13 over 3. Okay? So just some busy work here. 13. 13, we have 2, 4, and then something. Okay, so how it goes. Theta is up on top, 2, 4. Okay, so we got to find out what this is. So these are a and b. 2 squared plus x squared is 4 squared. 4 plus x squared equals 16. Subtract 4 on each side. X squared is 12. We square root. And radical 12 is the same as radical 4 times radical 3, which is 2 radical 3. 2 radical 3. So sine, cosine, and tangent. Sine is opposite over hypotenuse. 2 radical 3 over 4. And that simplifies 2/4 is 1/2, so radical 3 over 2. Cosine is adjacent over hypotenuse, 2 over 4, which is 1/2. And tangent is 2 opposite over adjacent, 2 radical 3 over 2, which is 2 radical 3 over 2. The 2's cancel, you just have radical 3. Supposed to say radical 3. So we have cotangent, secant, and cosecant. I'm going to do secant first, flip 2 over 1 over 2, you have 2 over 1. The reciprocal of radical 3, from that little shortcut I showed you a long time ago, is radical 3 over 3. If you flip radical 3 over 2, you have 2 over radical 3 times radical 3, you have 2 radical 3 over 3. Okay? Okay, let's erase some of this. Or do I have room? I might have room over here that I can get this. Let's just get rid of this triangle. We don't need this. Okay, let's look at number 15. So we have 2, 1, and theta. Okay, so I gotta find what x is. So we have 1 squared plus radical 2 squared equals x squared. 1 squared is 1, radical 2 squared, these cancel, you have 2 equals x squared. 1 and 2 is 3 is x squared. Square root it, you get x equals radical 3. Goes sine, cosine, and tangent. Sine is, I have that in the right spot. Where are we? This is number 15, down there. Yes. Okay, sine is opposite over hypotenuse, radical 2 over radical 3. 2 over radical 3. And times by radical 3 to get the radical off bottom. You get radical 6 over 3. Cosine is adjacent over hypotenuse, 1 over radical 3. Times radical 3, you get radical 3 over 3. And tangent is opposite over adjacent, radical 2 over 1, which is radical 2. Cotangent, secant, and cosecant. Well, Well, it's reciprocal of radical 2 is radical 2 over 2, that little shortcut I just talked about a few minutes ago. Flip 1 over radical 3, it's radical 3 over 1. And flip radical 6 over 3 would be 3 over radical 6 times our radical 6. You have 3 radical, that was terrible. 3 radical 6 over 6. 3 sixths is 1/2, so you get radical 6 over 2. Okay, sorry about that. That kind of went into number 11 there. Okay, all right, that's at number 15. One more of these, and we got to start talking about some other stuff. Okay, so let's look at number 15. We just do 15. 17. Number 17. So they give us this triangle, 1 theta, radical 5. Okay. So we got to find out what x is right here. And again, we can use Pythagorean theorem because these are right triangles. If they weren't right triangles, you couldn't use Pythagorean theorem. We'll talk about that more in the next couple sections. So x squared plus 1 squared is radical 5 squared. X squared plus 1 equals, these cancel 5. Subtract 1 each side, x squared equals 4. Square root each side, x is 2. So sine, cosine, tangent. Sine is opposite over hypotenuse, 1 over radical 5. And times our radical 5 on top and bottom, we're going to have radical 5 over 5. Cosine is adjacent over hypotenuse, 2 over radical 5. Times our radical 5, we're going to have 2 radical 5 over 5. And tangent is opposite over adjacent, so 1 over 2 is 1/2. Cotangent, secant, and cosecant. Flip 1 over 2, you have 2 over 1. I'm going to flip 1 over radical 5, it's radical 5 over 1. Flip 2 over radical 5, it's radical 5 over 2. Okay, so those aren't that bad. Okay, now, something that I think we might have mentioned briefly way back a few months back, a month or two back, I'm going to talk about again, are cofunctions. Okay, cofunctions. If I was to give you sine, cosine, tangent, cotangent, secant, and cosecant, sine and cosine, we're going to label as cofunctions. You might want to jot this on the back of your unit circle. Okay, this is important information that you're going to want to use. Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Cosecant and secant are cofunctions. Now, I have no idea what the sine of 5 degrees is, but I know it's the same as a cosine of 85 degrees. Okay? And I'm going to tell you how I know that in just a second. If I had said the tangent of 10 degrees, I don't know what that is, but I know it's the same as the cotangent of 80 degrees. What is so special about these? Sine and cosine are cofunctions, whatever that is. Tangent and cotangent are cofunctions, okay? These angles are not the same, but what do they have in common? 5 and 85, and 10 and 80, they both have to 90, okay? So if I was to say the cosecant of 20 degrees, cosecant's cofunction is secant, it's the same as the secant of what adds up to 90? 70. I have no idea what either one of those are, but they're the same, okay? So what you need to understand are complements. You remember from geometry, not compliments like, hey, good job, you did a good job there. That's not that kind of compliment. Okay, complementary angles up to 90. Okay, complements of cofunctions are congruent. They're the same. Whatever they are, they're the same. Okay. Now, if I give you this right here, the sine of 40 degrees, does that equal the tangent of 50 degrees? Those are complementary angles. Are they the same though? No, because sine and tangent are not cofunctions, okay? It would have to be cotangent and tangent, okay? Or if I give you this, the sine of 30 degrees, does that equal the cosine of 50 degrees? Sine and cosine are cofunctions, but 30 and 50 are not complementary. They're not the same, okay? So as long as they're two different cofunctions, and they both add up to 90 degrees, the complements are the same, okay? So how we're going to use that is this. These are going to be some really quick questions, okay? When we look at question number 19, they ask us, what's the sine of 38 minus the cosine of 52 degrees? They want you to do this without a calculator, okay? Now, I can't stop you from using a calculator. You shouldn't need a calculator, okay? Sine and cosine are cofunctions. These are complementary. They're the same. So whatever this is the same. And if you subtract something from the same number, you get 0. Piece of cake. 21. Cosine 10, sine 80. Excuse me. Okay. I don't know what the cosine of 10 or the sine of 80 is, but I know that cosine and sine are cofunctions, and these are complementary. They add up to 90, so these two numbers are the same. When you divide a number by itself, you don't get 0, you get 1. 23. 1 minus cosine squared, 20 degrees, minus cosine squared, 70 degrees. Okay, well, if you remember, 1 minus cosine squared is the same as sine squared of 20 degrees. Okay, now, these are cofunctions, and they're complementary. So these are the same, okay? So when you subtract them, you get 0. Well, squared. Well, 0 squared is 0. Okay, so again, 1 minus cosine squared is sine squared. These are cofunctions, they're complementary, they're the same. When you subtract something from itself, you get 1. I'm sorry, you get 0, and 0 squared is 0. 25. Tangent of 20 minus cosine 70 over cosine 20. Okay, well, what I could do is this. I'm going to make these all the same angle. I'm going to make them all 20 because I have 20 here, 20 here. I'm going to make that 20. Cosine of 70 is the same as the sine of 20 because those are cofunctions and those are complementary. Sine over cosine is tangent as long as the angle is the same, and it is now. So it's the tangent of 20. I don't know what tangent 20 is. When I subtract tangent 20 minus tangent 20, you get 0 because they're the same thing. When you subtract something from itself, you get the same thing. 27. Last one of these. Okay, so we have cosine 35, sine 55. Sine 35, cosine 55. Let's make them all the same angle, okay? Okay, so I could do this right here. Cosine 35 is the same as the sine of 55, okay? Because these are cofunctions and these are complementary. Times the sine of 55 plus cosine of 35 is the same as the cosine of 55 degrees because these are cofunctions and these are complementary. Cosine of 55. Well, sine of 55 times sine of 55 is sine squared of 55 degrees. Cosine of 55 times cosine of 55. You can do that because cosine times cosine is cosine squared as long as the angles are the same, and they are. So cosine squared of 55. Sine squared plus cosine squared is 1 as long as the angle's the same, and it is. They're both 55. So this is 1. Okay? All right. Okay, so the last things we have to do, these last 6 or 7 questions, is we're solving triangles, okay? Solving right triangles. The next section, section 4-2, we're going to be solving non-right triangles, okay? Well, we're going to be solving right triangles now. Okay, so here's what we're going to do. They give you a triangle, okay, it's number 29, okay, and they label this for every one of these. We have A up here, B over here, and then C. And then they label this little a, little c, little b. I mean, you should know that. The angle is always across from the side. Okay, so number 29. B is 5, little b is 5. B is 20 degrees. And then they tell us well, C is 90, because we know it's 90 because it has the box there, okay? So, what I would like you to do on your homework is I want you to draw pictures, okay? I want a picture. Okay, I'm going to tell you right now, if you don't have a picture, if you just say little a is this, little b is this, little c is this, I'm going to mark you wrong. I want to see a picture, okay? So I drew a picture. So we got to find big A, little a, and little c. It doesn't matter what we find first. I like to find the easy stuff first, though, okay? The easiest one is capital A. If this is 90, these two together have to add up to 90 because all three of them add up to 180. You knew that. So if that's 90, this has to be 70. I'm not going to show how to work on that. 20 and 70 is 90, 90 and 90 is 180, okay? So we got to find little a and little c. It doesn't matter what I find first. Now, we can't use the Pythagorean theorem here. Pythagorean theorem, you have to have two sides. We only have one side. We don't have the other two. We can't use the Pythagorean theorem. So here's what we're going to do. There's more than one way you could do these, more than one way. So what I'm going to do is this. I'm going to find little a next, okay? Now, I have this side. So I could use either 20 degrees or 70 degrees. It doesn't matter. It doesn't matter, okay? Use the non-right angle, okay? Just it's easier if you use the non-right angle, okay? So if I'm going to use this right here, these two sides, this is opposite from it, and this is adjacent to it. So that's tangent. Opposite and adjacent are tangent. So the tangent of 70 degrees equals a over 5. And then to solve that for a, we times each side by 5. So a equals 5 times the tangent of 70. I'm going to type that in the calculator in a minute, okay? And then we still need to find c, okay? So I'm going to get rid of this. I'm going to type that in right now. 5 tangent. So if you're going to type these in on your calculator, make sure you're in degree mode. Oh, that's another thing that's good about this, is we are done with radians, okay? We're all done with radians. So don't worry about those. So make sure you're in degree mode. So we type in 5 tangent 70. And I only want a couple, this is like 13.7. 13.7. So A is 13.7. Now, could we use Pythagorean theorem here? No. We could. We're not going to, though. And here's why. This is not 13.7. It's about 13.7, okay? So we're not going to use this, okay? I'm going to still stick with 70, and these are the two sides I'm going to use. I could use this, but I don't want to. It's only an approximation. That's an exact value, okay? So these two sides, this is adjacent, and this is hypotenuse. So we're dealing with cosine. The cosine of 70 degrees equals 5 over c. Okay? I want to show you a little shortcut right here, okay? If A is on top, we just times each side by the bottom number, it's gone, okay? Well, in this case, C is on bottom. Here's the long way of doing it. Just watch for a second here, okay? If we times each side by C, we'd have C cosine 70 equals, these cancel, equals 5. And then to solve for C, we divide by cosine 70 degrees. This is not the way I want you doing it. This is the long way. C equals 5 over cosine 70. So here's what I'd like you to do. Rather than do all those steps, if your variable's on top, you just times each side by the bottom number. If your variable's on bottom, look at this and look at this. It's the same thing, except for we just switched these. The C went here, the cosine 70 went there. So if your variable's on bottom, just switch those, okay? That's a little bit quicker. That's the way I'm going to do it from this point forward, okay? C is on bottom, so switch C here and put that there. So C is 5 over cosine 70. We didn't do that here because your variable is on top, okay? All right, so we type in 5 divided by cosine 70, and you get about 14.6. Now, something I've not told you, but I think you all know this. You're all done with this problem, but I would do a quick check. And what I mean by a quick check is, do the answers make sense? And what I mean by make sense is this. On any triangle, you're going to find the biggest side across from the biggest angle and the small side across from the smallest angle, okay? This is our biggest angle. Is that the biggest side? Yep, 14.6 is the biggest. That's my smallest angle. Is that across from the small side? Yes, it is. Did that prove that we did it right? No. But if your biggest side is not across from your biggest angle, you made a mistake. Or if your smallest angle is not across from your small side, you made a mistake, okay? Since it makes sense, it's a good chance we did it right, okay? You don't have to do that. I just think it's a good idea. It takes 2 seconds to check, Just make sure that your biggest side's across from the biggest angle, and the same thing with the small side, the smallest angle. So number 31, draw our picture again. So we have A, B, and C again. What did they tell us here? 31, we have A is 6, little a is 6, B is 40 degrees. Got to find everything else, okay? So again, capital A has got to be 50. It's got to be. These have to add to 90 because that's 90, okay? So we got little b and little c, okay? I'm going to pick this angle first. It doesn't matter which one I use other than don't use the right angle, okay? And the reason why I wouldn't use the right angle is if you're using tangent, if you remember on a unit circle, if we're using 90 degrees, the tangent at 90 is undefined. So I would avoid the 90, okay? So I'm going to find little b first. It doesn't matter which one I find first. I typically find them alphabetically, okay? So I want little b, and I'm not going to use x. I don't know. I'm going to use this. So these two sides, if I'm using 40, and again, why did I use 40? It doesn't matter. I could have used 50. It doesn't matter, but you got to pick one. So this and this are opposite and adjacent. So again, it's tangent of 40 degrees equals b over 6. Am I going to use that little trick I just showed you a second ago? No, because your variable's on top. We simply times by 6. So 6 tangent of 40 equals b. And if we type that in, 6 tangent of 40, we get about 5.0. And it's not 5.0, it's 5.0 something, 5.034-ish. And then I want to find C. So I'm going to use 6 and C, and I'm still going to stick with 40. This is adjacent, and this is hypotenuse. So I'm going to use cosine of 40 equals 6 over C. Here C is on bottom, so switch these. Little c is 6 over cosine 40. So we type in 6 divided by cosine 40. we get 7.8. Okay. And my biggest side, biggest angle, smallest side, smallest angle. We didn't prove it's right, but it's, probably it's right, and it is. Okay. Unless I type something in wrong. 33. Same picture here. We got capital A, capital B, capital C. B is 4. A is 10. Gotta find everything else. Okay, hopefully your picture looks better than mine. That looks terrible. So that's 10. That's got to be 80. Okay. So I got to find a little a, a little c. I'm going to find a little a first. I'm going to use this side. I'm going to use this angle again. I'm just flip-flopping. It doesn't really matter which one to do. So I use this angle on these two sides. This is opposite, and this is adjacent, so it's tangent. Tangent of 10 degrees is a over 4. That's a, not 9. Times by 4. 4 tangent of 10 is a. So we type in 4 tangent of 10. Do that, we get 0.71. About 0.71. And now I want to find C, so I'm going to use these two again. It's not 7.1, it's about 0.71. So these two are adjacent and hypotenuse. So we're going to use cosine of 10 degrees is 4 over C. C is on bottom, so switch them. C is 4 over cosine 10. So 4 divided by cosine 10. We get about 4.1. Okay, and that is very small because that's a very small angle. That's the biggest, and this right here, 4.1, is really close to 4 because 80 and 90 are not that far apart. So the sides opposite them shouldn't be that far apart. Okay? All right, just a few more and then we're done with this section. 33. Okay, 35. Oops, 35. Okay, so we get A, B, and C. We have A is 5, A is 25. Gotta find everything else, okay? All right, so this is 25. This right here's got to be what, 65? So 80, 90. Because you have to have 90 because 99 is 180. So we got to find a little C and a little B. We find a little B first. I'm gonna go back to this angle. It doesn't matter which one I use, okay? It's not like one's easier or tougher than the other, okay? It really doesn't matter. So if I'm going to find B, I'm going to use this side. This is opposite and adjacent. So I'm going to use tangent of 65 degrees equals B over 5 times each side by 5. B is 5 times the tangent of 65. Okay, I'll type that in a second. And then if I want to find C, I'm going to use these two sides of 65. This is adjacent and hypotenuse. So I'm going to have cosine. Cosine of 65 degrees equals 5 over C. C is on bottom. Let's switch them. So C equals 5 over cosine of 65 degrees. So we type those in, and we get 5 tangent of 65. So 10.7. And 5 divided by cosine 65. 11.8. So 11.8. 10.7. Oops, 10.7 right there. All right, almost done with this section. Okay, 37, 3 more to go. Okay, C is 9, B is 20, so A is going to be 70. Here's a little b, here's a little a. Okay? Okay, so I'm going to find a little a first. I'm going to go to this one. Okay, so we have, I'm going to use this and this because I don't know what b is. We can't have two unknowns, we can only have one unknown. So opposite and hypotenuse, so the sine of 70 equals opposite over hypotenuse, a over 9. Well, let's say 9 over 9. This must be a little a over a 9. So we times each side by 9, so little a is 9 times the sine of 70. We'll type that in a few minutes. And then in order to find little b, we're going to use these two sides. This is adjacent and hypotenuse, so that's going to be cosine. 70 degrees is b over 9. So we times each side by 9. b is 9 cosine 70. So we type in 9 sine 70 You get about 8.5. 9 cosine 70. You get about 3.1. Okay, so A is 8.5 and B is 3.1. Excuse me, it's in my throat. And again, I haven't been doing this on the last few, I should have. Here's my smallest angle, that is a small side, that's my biggest angle, that's the biggest side. So again, that doesn't prove we did it right, but it tells us we're, it's reasonable answers. Doesn't mean it's necessarily right though. 2 more to go. Okay, now, in this case, a little bit different information. They give us little a is 5 and little b is 3. It'd be nice if it was, if that was 5, it would be 3, 4, 5. But this is not a 3, 4, 5 triangle. It can't be because that's got to be the long side, and long side can't be 4 because 5 is bigger. So we got to find little c. So we can't find capital A or capital B. We know they add up to 90, but we don't know either one of these, okay? So we've got to find out little c first. So in this case, we got to use Pythagorean theorem, okay? So 3 squared plus 5 squared equals c squared. 9 plus 25 is c squared. 34 is c squared, and then we square root it, and I want an approximation, okay? The exact answer is the square root of 34. We type in the square root of 34, and we get about 5.8. So c is 5.8, okay? And then I'm gonna find I gotta find capital A and capital B. I'm gonna find capital A first, okay? I'm gonna use these 2 sides because these are exact answers. There's an approximate answer. So this is opposite from A, opposite and adjacent. So it's gonna be the tangent. The tangent of capital A is 5/3. Now let's go back a month or two. How do you get rid of tangent? You don't divide by tangent. You take the inverse tangent. Okay, take the inverse tangent of each side. The inverse tangent. So I wrote this all out. The inverse tangent of the tangent of A equals the inverse tangent of 5/3. So just inverse tangent of each side. These cancel each other out. Left with capital A is the inverse tangent of 5/3. So on your calculator, type second function tangent. 5 divided by 3. You do that and you get about 59. So A is 59. Now, A is 59. Do I have to do that in order to find out B? No. These have to add up to 90, so that's 59. That's going to be 31. Okay, because I have to add up to 90. 41. Last one. Okay, so we have little a, capital B, and C. Little a is 2. Little c is 5. We've got to find out what B is. Okay, so let's use Pythagorean theorem. 2 squared plus b squared is 5 squared. 4 plus b squared is 25. Subtract 4 to each side. B squared is 21. Square root of 21. Okay, second square root of 21. Get about 4.6. Okay. All right, and then I want to find out what capital A and capital B are. I'm going to find capital A first. It doesn't matter. I'm going to use these 2 sides, though. So this is opposite and hypotenuse. So the sine of capital A is opposite over hypotenuse, 2/5. Take the inverse sine of each side. So we type in the inverse sine of 2/5. So second function sine of 2/5. And you get about 23.6. These have to add up to 90, so we take 90 minus 23.6, and we get 66.4. Is that correct? 89. Yeah, 66.4. Okay. All right. Questions on this? Of course not. There's nobody here. Okay. So if you do have questions, though, email me. I'll get back with you as soon as I can. Again, we'll have our homework quiz on Thursday of this week over section 4-1. Okay. Talk to you guys later. See you.